Hello, I'm Steve Reyes from Anritsu. Today what we're showing is the new VectorStar broadband system that sweeps from 70 kilohertz to 145 gigahertz in a single sweep. What we have is a microwave VNA that is sweeping from 70 kilohertz up to 70 gigahertz, and that's the model we're using for generating the frequencies in the baseband. And those frequencies are coming to the module and transmitting through the transmission line from 70 kilohertz to actually 54 gigahertz. And then we have our nonlinear transmission line modules that Anritsu develops using the shock line technology that propagates and multiplies the signal all the way to 145. The way that we do that is we have multiple bands, multiplier bands, that go from 54 to 80, 80 to 110, and 110 to 145. And that's basically coming off of the previous modules that we have been developing that goes to 110 and 125 gigahertz. So the first introduction of the nonlinear transmission line modules went up to 110 and 125. And they propagated, or they distributed their signal test port in a 1 millimeter connector. And the fact that we were able to make the module so small with very high RF performance and very good stability has given us a number of options in terms of setup and configuration. So you can see with the 110 modules that we have a differential setup driving a differential probe going all the way up to 110 gigahertz. And so we've taken that nonlinear transmission line technology, added that next band in, and now have these new modules that go to 145. So with the 145, the issue there is that 1 millimeter connector, which basically can go up to about 110. What we've done is, basically developed and designed a new connector, 0.8 millimeter geometry. And Anritsu has always been a pioneer in connector introductions at higher frequencies, starting with the K connector going to 40 gigahertz, the V connector going to 70, and now we have the 0.8 going to 145. So now we have a DC to 145 connector that we can use as our test port in the module. And that connector is supported by a coaxial cal kit as well as verification kit. But for on-wafer measurements, we now are connected to a probe that is a GGB with 0.8 connector, and we're able to make measurements all the way to 145 in a broadband configuration. And doing LRM calibrations, we're getting directivities in the range of high 30s to the 40 dB range. So the stability, accuracy is still there. The capabilities to be able to sweep even to higher frequencies we're now providing as a new benefit for the device characterization customers. Thank you.